Hi, everybody. It's Professor Mitchell. Continuing in Chapter 6, now we're doing the Law of Cosines. So remember from the last section, Law of Sines. Law of Sines and also Law of Cosines, it turns out, are used for solving oblique triangles. An oblique triangle is a triangle that does not have a right angle. Okay. Let's see. Okay. So we're going to use the law of cosines to solve oblique triangles. We're going to do an application problem or two. And then it turns out that law of cosines has its own version of the area formula for a triangle that comes from the law of cosines. Okay. All right. Now, I think I mentioned in the law of sines video that if I have a choice between using the law of sines or the law of cosines, I'm going to use the law of sines if I can get away with it. It tends to be a little simpler. But you can't always use the law of sines. I kind of wish I had the law of sines written down here. But remember that it has those ratios, A over sine A equals B over sine B equals C over sine C. And the only way that you can use the law of sines is if you have enough information to complete one of those ratios. Okay, so a side and the opposite angle will complete one of those ratios. So these are the two situations where you do not have enough information to complete any of those ratios. Let's talk about this one first. It's a little simpler. Side, side, side. Having the three sides of a triangle will nail down the triangle. Okay, you can figure out the angles given the three sides. However, if you just have the three sides, what is that? That's little a, little b, little c. So that's not enough information to complete any of the ratios in the law of sines. And SAS is another example. So this would be like you have side A, side B, and angle C. Okay. In law of sines, I think they always gave us two angles. They always gave us two angles. So we had enough information to figure out the third angle, and then we were able to complete a ratio. Okay. So the law of sines says this, and there are three different versions of it depending on which angle you have, if any. Okay. Notice, I like to point this out. Notice that the beginning of the law of sines looks just like the Pythagorean theorem. You see that? Okay. So if this was a right triangle, that's all I would need. All right. And actually, in that case, these would not all be interchangeable, right? Because we always call the longest side of a right triangle angle side C. Okay. In an oblique triangle, we don't care. We just slap an A, B, and C on whichever ones we want. Okay. But when your triangle is not a right triangle, then you then have to subtract this other term, and there is kind of a nice pattern to it. I like to talk about this one because it looks the most like, the Pythagorean theorem that you're used to, right? So it goes C squared equals A squared plus B squared, but then you have to subtract a 2AB cosine C. Okay. So whichever two sides are mentioned over here, those two sides go also in this term, and then the angle is the one opposite the side that's over here. So again, just two situations, side, angle, side. In that case, they're going to give you an angle, and you will very easily be able to decide which one of these you want to use. Okay. Or if they give you side, 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 then it really doesn't matter which one of these you use. Really just use whichever one you want. I think the book might have some advice about which one they think you should use, but I don't think it's all that important. All right, so here they give you a list of recommended steps for solving an SAS triangle. Remember, that means two sides and the included angle. So first we're going to use the law of cosines to find the side opposite the given angle. So this was the situation I was talking about where, you'll very easily decide which version of the law of sines you want to use. Okay. Step 2, they say use the law of sines to find the angle opposite the shorter of the two given sides. And now I think I understand why they're recommending the shorter of the two given sides. It's because every triangle has, of course, at least one acute angle, right? Actually, at least two acute angles. And so if you pick the shorter of the two given sides, the angle opposite that side is guaranteed to be acute. And so you don't have to play this guessing game, that we talked about yesterday, where you take the inverse sine, and I don't know if it's the quadrant 1 or the quadrant 2 angle. So I think that is good advice, actually. And then find the third angle just using the fact that the three angles add up to 180. Okay. Okay, first example of using law of cosines. So this is SAS. They have given me two sides, B equals 7, C equals 8, and then angle A is 120 degrees. So I know that this angle is included because it's using, the different letter from the two sides. Okay. And they're giving me my rounding instructions. All right, so because they've given me angle A, I am going to use the version of the law of sines that starts with A squared. A squared equals B squared plus C squared minus 2BC cosine A. How did I do? Woohoo. Okay. And there's a picture of that triangle. Okay, so what do we have? We have B, we have C, and we have angle A. So we'll go ahead and plug all of that in. A squared is equal to 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of 120 degrees. All right, the cosine of 120 degrees happens to be exactly -1/2. If you forgot that for a second, it wouldn't really matter. We're not really after exact values in this section. Okay. Wow, they really rigged this one to come out nice. Turns out that A squared is 169, which means A is exactly 13. Okay, so now we have side A is 13. We have all three sides and we have one angle, so we have enough information to complete the A ratio in the law of sines. We have side A and we have angle A. So what we're going to do now is we're going to use that ratio that we have to figure out the angle opposite the shorter side. And again, the reason they suggest you pick the shorter side is because they guarantee that will always be acute. It just so happens in this problem that the angle that they gave me was obtuse, which already guarantees that both of these other angles are acute. But anyway, it's good advice. It's not super critical advice, but I like it. Okay, so remember this from the law of sines. The law of sines says that A over sine A is equal to B over sine B, and those are both equal to C over sine C, right? And usually we just work with two of those ratios at a time. And then we cross multiply. Remember that? We multiply this times this, and we set that equal to this times this. So that's going to, that's going to give me B sine A equals A sine B. So I am trying to solve for angle B. So I need to divide both sides of this by little a. Right? And that is going to give me sine B is equal to B sine A divided by A. 7 sine 120 degrees divided by 13 is about 0.4663. And because we know that this unknown angle is acute, we can count on the calculator to give us the right value. We do not have to worry about this angle being in quadrant 2, okay? Like we sometimes did in the last section. All right, so you ask the calculator, what's the inverse sine of 0.4663? To the nearest degree, it is about 28 degrees. All right, so now that we have all 3 sides and we have 2 angles, it's very easy to find the last angle. You just use the fact that all 3 angles add up to 180 degrees. So the given angle, was 120 degrees. We just found angle B is 28 degrees, which means angle C has to be 32 degrees. All right. So that brings us to the SSS case. This is where they give you all 3 sides. Again, not enough information to complete a ratio for law of sines. So their advice is to start by using the law of cosines to find the angle opposite the longest side. So, so I guess they want you to call the longest side little c, which is consistent with that's consistent with what we do with right triangles, right? So call the longest side C, and use the third form of the. Actually, they didn't say that at all, did they? But I think that would be a good way to do it. All right. Okay. And then use the law of sines to find either one of the 2 remaining angles. So if you follow their advice and find the largest angle first, remember the largest angle is opposite the longest side. The other 2 angles are guaranteed to be acute. All right, so you do not have to worry about any of that, weirdness again with inverse sine. Sometimes giving you the angle you want, but sometimes not, because sometimes you have to go into quadrant 2. Okay. All right, so let's look. They want me to solve this triangle where the 3 sides are 8, 10, and 5. Okay. Oh, I see. Okay, so if they give names to the 3 sides, well then, and you follow their advice about find the angle opposite the longest side first, then that's going to dictate which form of the law of cosines you use. Okay. So they're calling the longest side B. So I guess they're going to use the second form. All right. So how does that go? B squared equals A squared plus C squared minus 2AC cosine B. Is that the one they're going to use? Yes, it is. Okay. So we're using the law of sines to find the angle opposite the longest side. The longest side is B. Okay. All right, so now when you plug these things into the formula, you get, oh, I see what they're doing. Okay. They're solving this formula for cosine B first. All right, you don't really have to do that. What I thought they were going to do was just plug in the numbers and then solve it for cosine B. But either way, so let's see if we can follow what they did. It looks to me like the first thing they did, let me I set to draw here. So they started by adding 2AC cosine B to both sides, and then they went ahead and subtracted B squared from both sides. I might have thought about doing this in 2 steps. Okay. So that minus B squared kills that, and those 2 are out. So that leaves you with 2AC cosine B. I'm sorry, that's a typo. That should say C. 2AC cosine B equals A squared plus C squared minus B squared. Let me just show you really quick how it would look if you just plugged in the numbers right at the beginning. You might find it a little simpler. All right, so going from the first version of the formula, let me get rid of all my scribble here. You can do this whichever way you find simpler. Oh, I know what happened. Okay. hold on just a sec. Okay, as I was saying, they decided to start by solving this formula for cosine B and then plugging in all the numbers. The way that I would personally do it is I would probably plug in the numbers first. And if I plug in the numbers first, I get 10 squared equals, A is 8, so 8 squared plus C is 5, 5 squared, minus 2 times 8 times 5 cosine B, which leaves me 100 equals 64 plus 25. 2 times 8 is 40. 40 times 5 is 2. No, that's not right. 16 times 5 is 80. 80 cosine B. Sorry about my bad handwriting. Maybe it'll be better if I go up here. Okay, so 100, or maybe not, equals 89 minus, come on now. 100 equals 89 minus 80 cosine B. Oh, that's awful. Subtract 89 from both sides, and that will give you 11 equals negative 80 cosine B. You divide both sides by negative 80. And you get that the cosine of B is equal to negative 11 over 80. Okay. And then we will use the calculator and the inverse cosine function to figure out what angle B is. Okay, so now just so I don't completely ruin the flow of the problem, I'll go back to the way they did it just to show you you get the same thing. So again, they solved the formula for cosine B, and they also found that the cosine of B is negative 11 over 80. They just did it a slightly different way. So if the cosine of B is negative 11 over 80, that means that B is the inverse cosine. I forgot to put a B here, and I take the blame for that because I recognize my font here. I put that in. There was something about the way they had this typed out that I didn't like. So B is the inverse cosine of negative 11 over 80, and that is about, that really should be a wiggly equals, about 98 degrees. Okay, so the next step is to use the law of sines to find either of the two remaining angles, which are guaranteed to both be acute. And they chose angle A. So again, I bet they're going to cross multiply these. Oh, they skipped that step. All right. They did cross multiply them, and then they went right ahead and divided both sides by B. That was sneaky of them. Okay, so B sine A. See, now I'm trying to use the mouse, which is slightly neater, but is also a lot slower. All right. That's equal to A sine B, and then they divided both sides by little b, right? So that's how they got that. All right, so I plug in A is 8. I plug in 98 degrees for B. I plug in 10 for little b. The sine of A is about 0.7922. So now if you take the inverse sine of that, that gives you angle A, which is about 52 degrees. Angle A is about 52 degrees. All right, so now all the hard work is over. Of course, we were given all three sides and we found two of the angles. So to find the third angle, you just use the fact that they add up to 180 degrees. Angle C, it turns out, is about 30 degrees. So in summary, A is about 52 degrees, B is about 98 degrees, C is about 30 degrees. All right, so that brings us to an application problem. Now, when you first read these, you're not going to know whether to use law of sines or law of cosines. So the first thing you definitely want to do with any of these word problems is draw a picture. All right, so this one starts off the way a lot of word problems that everybody makes fun of starts off. Two airplanes leave an airport at the same time on different runways. One flies directly north at 400 miles an hour. The other airplane flies on a bearing of north 75 degrees east at 350 miles per hour. How far apart will the airplanes be after 2 hours? Okay, so let's draw a picture of that. Okay, so let me explain this picture. It's asking how far apart will the airplanes be after 2 hours. So instead of telling you that the first airplane flew 800 miles, they're being a little more subtle about it. They're saying it flew 400 miles per hour for 2 hours. So we're using the distance equals rate times time formula that you've hopefully seen before. So here is the time, and here is the rate. And when you multiply those together, they're going to give you the distance, okay? So the first airplane flew, let me try that again. That R does not look like an R. That's a little better. Okay, so the first airplane flew 800 miles, and then the same kind of idea with the other one. It flew 350 miles per hour for 2 hours. So once again, time times rate equals distance. Okay. All right. I'm trying to figure out how they chose these. Oh, never mind. I was reading it wrong. I was looking at the S down here. I was like, why are they calling that angle S? That S is for south, right? So they are calling the angles A, B, and C. And then remember how your bearings work. North 75 degrees east means start off going north, but then go 75 degrees this way from the north, okay? So that does mean in my triangle, angle B is 75 degrees. And I guess this side here would be called, what would it be called? It would be called C, little c. Where should I put that? I'll put it over here. And this side here would be called little b, okay? So we have little b, we have little c. No, that's not right. That would be A, right? Sorry, looking at the wrong thing. This is angle A over here. The side opposite angle A would be called little a. Okay, so we have little a is 700. We have little c is 800, and we have angle B. So this is an example of side angle side. Not enough information to complete a law of sines ratio. So we have to use law of cosines, and we're going to use the version that starts off with b squared, right? Because that's the one that has angle B in it. All right, so b squared is equal to a squared plus c squared minus 2ac cosine b. And by the way, I should mention that we're trying to find side B, right? Because that'll be the distance between the two airplanes. The one airplane ends up right here. The other airplane ends up right here. Okay, so we are trying to find side B of this triangle. All right, So side A is 700, side C is 800, angle B is 75 degrees. So you crunch those numbers and you get the B squared is about 840,122 and some change. You take the square root and you get that side B of this triangle is about 917. So after 2 hours, these airplanes are about 917 miles apart. All right. So you may remember that in Law of Sines, Law of Sines gave us a certain area formula for a triangle. This one looks a lot different, and it is derived from the Law of Cosines. Again, I won't bore you with the details because I'm not sure I remember how. This is called Heron's formula, and what it says is that if you are given the sides A, B, and C of a triangle, the area of that triangle is the square root of S times S minus A times S minus B times S minus C. So what is S? S is called the semi-perimeter. The semi-perimeter, which is just 1/2 the perimeter. All right, so example of using Heron's formula. They want me to find the area of the triangle with sides 6 meters, 16 meters, and 18 meters. Okay, so they've gone ahead and called those sides A, B, and C. So the first thing I have to do is find the semi-perimeter. The semi-perimeter is 1/2 the perimeter, so the perimeter is 6 plus 16 plus 18, which is 40. 1/2 of 40 is 20. Okay. So now I take my area formula, I put in 20 for S, and I put in 6, 16, and 18 for A, B, and C. And that looks like this. So let's see. Okay, so they've gone ahead and crunched those numbers. 20 minus 6 is 14. 20 minus 16 is 4. 20 minus 18 is 2. 20 times 14 times 4 times 2 comes out to 2,240. And to the nearest whole number, the square root of 2,240 is about 47. So the area of this triangle is about 47 square meters. And that is the end